Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and today we're going to be building a uCARP installation on Alpine Linux. This is a great way to create high availability for services that are absolutely critical to you. So before we get into it, be sure to smash that like button and subscribe if you haven't subscribed, because we're about to get extended. Let's get into it. Okay, so what we have here is I have some virtual machines that I've spun up to be able to demonstrate this. My cat already is wanting to be part of the show. Let's see. You want to say hello? Look into the camera. Boop, 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 boop. There she is. You're going to sit on my lap? Okay, so what I have here are some virtual machines that I spun up to be able to actually do this demonstration. Just because I need two of them and I need to restart them pretty easily and I don't want to be messing around with the cables. So they're just clean installations of pretty recent version, maybe the most recent version of Alpine Linux at this point. The only thing I've done thus far is I've run setup Alpine already, and I've already pinged each VM in order to make sure that I can actually reach them. If the machines can't talk to each other, they're not going to be able to detect if one of them fails, so it's going to cause issues if you're trying to have it automatically fail over. And you could also have both machines turning on at the same time and taking over as master. So what this is going to do is it's going to share an IP address, right? So it's going to be a virtual IP. I realize I don't really have a place to draw, so let me minimize these really quick and we'll draw a little picture. Right, so we'll have a shared IP, which is called a virtual IP, or VIP. Okay, that is shared between these two hosts, okay? So we'll call it 1 and 2. But only one of them will be used at a time. So while one is active and is considered the master, it will be responding to requests for that virtual IP. But if one goes offline, now 2 would pick up and start responding to those requests. And we'll actually go through it and you'll see how that actually works, but things like web services, whatever else it is, you will have to reinitiate any socket connections, things like that. But it's a great way to make sure that an IP remains available, so you can use it for pretty much any service. So web being an excellent example of it, although there are other options in terms of load balancing for web. But like, let's say NTP, for example, where you need to have that ultra low delay, it will actually respond because it will actually be that machine's IP address, as if you were just talking to its regular physical IP address. So now that we've done that, let's go back to our first virtual machine. And what we're going to do is we're actually going to install uCARP. So to do that, I'll zoom in here for you, just because I don't think you have a chance of seeing this. We'll do apk search uCARP. And we see that there's two packages associated with it. One of them is the regular package itself, and the other one is the OpenRC. So this does come with a way to be able to start on startup very easily without having to write it yourself. Not all distributions do. Some distributions even make it even easier than that. But that's totally fine for our purposes, but I'll show you how to configure that as we go. So they'll both install if we do apk add uCARP. So we see those both installed, and now it adds, we want to make sure that we save this out, because again, this is just like it would be on a Raspberry Pi or anything else. We want to do lbu commit-d. So going on from there, we actually want to do the configuration. So we're going to do vi /etc /conf.d /uCARP. And this will show us the baseline for what is actually here. I'm sorry, I got to zoom the top of the screen. Maybe the middle? Yeah, we'll center this up. All right, so what we have here is the actual configuration file itself. First thing we have to do is set the interface. And I know because I only have one interface on this, and if you have a Raspberry Pi, you're only going to have one interface as well. If it's hardwired, it's going to be ETH0. But you can look that up by using ifconfig. Next is the source address. So for this, let's actually go out and take a look at that. So I just exited. Oh, this is going to be annoying to do that. That's fine. All right, so let's do ifconfig. And we see we have Ethernet 0 currently configured, and it has the address 192.168.40.122. So let's go back in and edit. And we're going to go down here to source address, and let's add that. So we're adding the IP address of the local interface, because that's what it's going to say it's coming from. Next, we're going to enter our virtual address, or that VIP address that's going to be shared between the two machines. This needs to be an address that's not already attached to any other machines, otherwise there will be an IP conflict. So in this case, let's do 192.168.40.80 arbitrarily. I know that one is free, and we'll verify that as well. Now, this part is very straightforward, but it's just what subnet are you actually going to broadcast across? So there's two ways to go about this. You can either use multicast, which is the default, or you can use broadcast, which goes across your own subnet. In our case, we're going to use multicast, so this doesn't really matter, but we're still going to have to set it because it is required as part of the default OpenRC service, I should say. So we're just going to do 24, which is appropriate for this network. Next is the virtual server ID. And this is very confusing, but just make it the same on all the servers that you want to share this address. So in this case, we'll just make it 1, but you could have up to 255 within the same subnet and not have them conflict. Remember, it doesn't know what the actual virtual address is across machines. It only cares about if the machines are alive, and then they'll take over. So if you have this misconfigured and it's crossing over across multiple IP addresses, you could get some very strange behavior. Next is the pass file here. And we see the uCARP pass file is /etc/uCARP/uCARP.pass. So let's go ahead and look inside that file. And I'll give you a hint. It doesn't exist. So I'm going to write this out, exit, and we'll do vi/etc/uCARP/uCARP doesn't exist .pass. And what we have is an empty file. So what we're going to enter is just the plain text version of it. Don't worry, it won't be transmitted in plain text. It will be encrypted or at least hashed before it actually sends it out. That's so it can make sure that nothing illegitimate is joining your cluster and trying to take over control. So we're just going to say this is password for now. We just got to make sure it matches on both machines. So I'm going to write that out, and I'm going to go back into our uCARP config. And this, you can't see it because of the arrow because of no VNC, but it says carp up script. And this is what actually runs when the interface comes up. And you can leave this as a default. It actually ships, it is in the package is a default script in order to make that virtual IP active. And that one's totally fine. You can always modify it though, but that's in etc uCARP as well. And same thing with the down script. And just to take a look at that really quick. So this is the up script, and it's not very complicated, but it's mainly doing IP address add, and it's adding pretty much your IP address with your subnet. So that's the reason it needs it on your device. And it has the alternative here available if you need it for ifconfig, but this works just fine. And the other one for if down removes it. So I'll show you here as well. And we see this is the down file, which again just deletes that address. That's all that's going on there. So not much happening. So back inside our config file, we have all of this set. Scrolling down here, last thing is additional uCARP options to pass. And right now it has -- shutdown, which means it's going to take it out of master for shutdown, which is going to make the failover a lot faster. There is another option that we can add here as well, which is -M, which will disable the multicast functionality and just use broadcast. So that may be an option that you want if your network does not support multicast, but again, it's something that you can choose based on your environment. So now we're fully configured. I'm going to write this out, exit from here, and just so in case you need it, you can always do uCARP from the command line, --help, and be able to see exactly what options exist. But we're not going to call it from the command line, although if you're troubleshooting, you can. So let's go ahead and start it. So we're going to do /etc /inetd /uCARP start. And we see it started. And if we do IP address, we can see that our address right here is currently set. So this is showing up as master. So that's the secondary IP address on Ethernet 0. So right now it's currently set, but we only have one machine in the cluster. So let's go ahead and add that second machine. So that way we can actually get this up and running so it'll be redundant. So we'll do same thing over here, apk add uCARP. It installs, we're going to do vi /etc /conf.d /uCARP. I'll fill this out really quick, but we're going to do Ethernet 0. The source address, again, is different. It's unique to this particular instance, which happens to be 123. So 168.40.123. I checked this ahead of time. Virtual IP address is going to be the same exact thing as our other machine. So it'll be 192.168.40.80. Our prefix will be our subnet mask, which will be 24. Our virtual server ID is going to be 1 to match the other server. We have to set our pass file, and that's it. So let's go ahead and do that. So we'll do vi. Let's do this. There we go. /etc /uCARP, and then uCARP.pass. And we'll do the same thing. So we'll enter a password and save it out. And then what we didn't do on the other one, but we need to do on both of these, is lbu commit -d. And we'll do the same thing over here as well. But we're ready to start it on this. So we'll do /etc /inetd /uCARP start. And it starts successfully. I'll run this again just for fun. But if we do IP address, we see that it currently does not have it set for Ethernet 0. Right? And that the reason for that is that we already have it on the other one. So right now it would make it so there would be an IP conflict because it would be serviced by 2 machines, and that would break your connections. So before we actually do any kind of web services or anything like that, let's just go ahead and ping it. So I'm going to bring up a command line here. Make it really small so I can fit it at the bottom here. And we're just going to do ping -t, and we're going to ping our virtual IP address. So it'll be 192.168.40.80. And we can see that start to scroll through. Right, so we've saved it on both machines. This is currently the one that's responding to it. So let's go ahead and reboot that machine and see what happens. So right now it's going down. We see this stalled for a second down here. But now it picked up. But this machine hasn't started back up yet. So if we run the same command over here, like we did before, we see that now it's responding to that IP address. So we see that it's successfully it's detected that other machine went down and has transitioned over the response, or who's responding to that IP address, to be able to make sure that those the services stay online. So now that we've done that, let's Control-C out of that. I'll drag this off the screen. We can actually install something. We'll install like a web server, just so we could see it. Where am I? Right. Oh, I'm clicking the wrong screen. So let's add, let's say, mini HTTPD. Yeah, okay, good. I didn't know if it was a dash or an underscore. I guessed correctly. So let's create a file inside of mini HTTPD. So we'll do vi / var www /html localhost htdocs. Okay, there we go. Sorry, I got my distributions confused. But var www localhost htdocs, and we'll call it index.html. And let's just make a simple file. We'll call it hello world 1. Oh, that just looks sloppy. There we go. Some very simple HTML. All right, so we just wrote that out. So now let's do the same thing on the other server. So we're going to do apk add /var www Oh, I'm sorry. apk add mini HTTPD. Now we could do vi / var www localhost htdocs index.html. We'll do the same exact thing, except this time it'll be hello world 2. So we'll write that out. Just a quick note on that. We do have to actually go through and add that explicitly to LBU. So we'll do LBU add / var www localhost htdocs index.html. So that way it gets preserved through reboots. And we'll do LBU commit -date. Same thing on the other server. anything in the etc folder that we edited before is automatically included in LBU, but anything in the var folder is not. So we can look at IP address again, and we see it's currently not responding on this server. So if we were to actually open up a web browser, there's a cat. There's a cat. Oh, cat. Cat. Don't step on the keyboard. Okay, so if we open up a web browser, what am I going to open? Yeah, I'll do this. There we go. So we'll go to our IP address, which is 192.168.40.80. We haven't started any of our servers. We should probably do that too. Boop. So same deal over here. Let's do, well, we actually have to make it so everything starts at once. So we need to do rc update, add, and we're going to do uCARP defaults, single default, and we'll also do mini HTTPD. I deleted the wrong thing, but that's okay. Perfect. And we can do that as well. I'm going to use the alternate thing, which is service mini HTTPD. Start. Perfect. LBU commit. And it's there. Do the same thing on the other one really quick. So we'll do rc update, add uCARP default. Same thing for mini HTTPD. Perfect. All right, and now when we open up our browser, we do see it says Hello World 2. All right, so now if we actually go through and we reboot number 2, let's make sure uCARP is running. Okay, now it is running. Let's give it a second just to detect. We'll do IP address. Over here. And we see currently it is not showing that IP address for the virtual IP. And same thing over here. So we'll do IP address as well. And we do see it showing up right here. So as soon as we reboot this instance, right, save our changes, and reboot, we now see it's going down. We look over here, we see it's picked it up immediately. If we refresh this page, it's not picking up. And the reason is because we didn't have that IP address in when we actually installed it. So it didn't automatically detect it. So, actually, I'm sorry, when we ran it, it didn't have it included. So if we do, since it has control of this IP address now, you can't see what I'm looking at. All right, so since this has the IP address, when we're looking at the top of the screen here, we see it's not coming up, right? So it still says hello world 2. So what's going on? So short form is it's not responding to requests from it for HTTPD. We have to restart it. And now it should be responding. Oh, we might actually have to config it. But let's just make sure. Yeah, so this is not responding. Okay, good. I did make them different, right? Let's see. Okay, so we're going to go in vi / etc should be mini httpd mini httpd.conf. We are going to have to go up to the top here. Right, so it's going to respond to port 80. Scrolling through here. Yeah, there's nothing that explicitly specifies what host or anything else like that that it's actually going to respond to. So it should be picking up our IP address since it is set. But I do want to just take a look at this. So ifconfig. Yeah, it doesn't show up here, so that could be a reason why it's not showing up. We may need to use actual Apache for this. So, short form is it's still not responding. It's still showing hello world 2. But it may be cached. Let me make sure it's not cached. 1 second. Oh, there we go. It was cached. Because I'm like, it's loading. Alright. So, it is working. We didn't set a timeout for the cache value, so I'd had to do Control F5 in order to get it to do a cache clearing refresh. And that's what caused it to reload. Otherwise, it just stayed on it because it was too similar. So it said, I already have this page. I don't need it again. So that's the reason why I did it. At the end of the day, that's annoying. But, okay. So we still have it here. Right? I did IP address, and we still have the actual IP address set here. So what I'll do now is, again, I will reboot this machine. Let's make sure that CARP is started over on this side. So we'll do service uCARP status, and we see it is started. And we'll do IP address, and we see it's not currently set. So over here, we'll reboot this. Right, so now this is going down. We'll do IP address over here. We see it picked it up. Now when we go up to the top right of the screen, look at this. We'll do a cache clearing refresh, and we see it's back to 2. So it has successfully failed over. If we did need to actually go through and make it restart any of our services for whatever reason, we could actually modify that up and down script to be able to do that on our behalf. So example being vi / etc / uCARP / vip, let's say up, default SSH. And up here, we could add additional things. So after it actually sets that, we could do service, let's say mini httpd restart, or just start it at all. So we could have it shut down while it's not actually running or needed. So that way you only have one service up at a time. But it's sometimes nice to have them both already running. And if you don't have to do that, you know, definitely no reason to do it. I am going to post all of this code inside of a GitHub, which will be available in the description after this stream, or really after the VOD if you're watching it after the fact. But that's pretty much the cool thing that I wanted to show you today. So it's really good for any kind of service, any kind of thing that you need to make sure is always available. And you can add more than just 2 nodes. You can have a cluster of, you know, as many as you want. As long as they're able to communicate over a network, they're able to actually go through and keep a track of whether the machine is up and be able to respond to maintain continuity in the event one of those servers fails. So thanks for watching the stream today. If you like it, be sure to hit that like button and leave a comment down below. And if you know anybody who would like this kind of content, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. And if you haven't subscribed, please subscribe. It helps me out a lot with the YouTube algorithm, and then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.